All right. Good afternoon, everybody. Sino ba nandito na? Good afternoon, Ben Paul and Ben Bemsor. So, ngayon, papagpatuloy lang natin yung where we left off last time. Actually, medyo mali pala yung pagkakabasa ko sa outline. I thought we'll be jumping to another type of pattern recognition algorithms on Unit 3.C, pero continuation pala siya. So, pattern recognition chapter 3B is about classification algorithms, and section or chapter 3C is about clustering algorithms. Kasi plano ko sana ngayon ay mag-K-means clustering algorithm tayo. And then next meeting, ano na ba next meeting? Next meeting will be December 9, which will be the last session for me. Another classification or another pattern recognition methods or class of algorithms yung i-discuss natin. So pwede pala tayo mag-discuss pa ng iba pang mga classification algorithms, because last time we're talking about the KNN or the K nearest neighbor classification algorithm. And that's basically the idea why beforehand I wanted you to read on the different type of distances and the different type of metrics. Kasi nga, kung nakita natin nung naglaro tayo ng KNN algorithm, ay nakadepende dun sa distance na i-declare mo kaya kay KNN yung magiging result ng classification. Because what KNN does is it classifies your data based on its K nearest neighbors. All right. So major takeaways there: different kind of distances or metrics or norm or metrics coming out of norms induces a different classification of the data. I think nakita natin to last time when we are looking at the petal width and the petal length as the determinants, or as the what you call this, as the attributes that will help us classify this observation or query data into the classifications we fed into our supervised learning algorithm, which is KNN nga. Kasi nakita natin nung Euclidean distance, the usual notion of distances na nasa isip natin. So halimbawa, we said find the 13 nearest neighbors with respect to the Euclidean distance. So sila yung physically pinakamalapit dun sa ating query point. Tapos magbobotohan yung 13 yon kung sino yung mananalo, yun yung i-declare natin to be the classification for that particular query point. So it sounds very simple, right? Though yun pala, hindi ka basta dapat nag-feed kasi ng data lamang. Kasi kailangan isipin mo, ano yung measure of distance? How near a neighbor should be, or with respect to what kind of nearness should we measure or should we find the neighbors? Kita natin kapag cosine similarity, yung ginawa nating or yung cosine distance, yung ginawa nating measure of being near or far, yung mga mas malalapit ay yung mga nasa straight line or pinakamalapit sa straight line passing through our query data. Kasi nga yung cosine similarity just measures the distance to be the cosine or to be the cosine of the angle between the two data points treated as vectors from a common point. So kaya yun yung lesson o yung takeaway dito. Hindi porket merong algorithm na built-in ay by default magfe-feed lang tayo ng data. Kailangan nating aralin kung ano yung mga different parameters that can affect the decision of these algorithms. So ano pa ba, may gusto pa nga ba akong sabihin about KNN? Let's see. Oh, maybe we can do it this way. Let's see. I want to try something. Hindi ko naabot kanina. I was playing with MATLAB earlier before I joined the meeting. May na-discover ako magandang feature ni MATLAB, tapos doon na naubos yung oras ko. Pero gawin muna natin siya mano-mano bago ko i-reveal yung na-discover ko kanina, because I still want to explore the different options. Kasi pagka gumagamit ako ng mga learning algorithms or ML algorithms kay MATLAB, mano-mano ko siya kinocode. Kinukuha ko lamang yung ano dapat yung syntax para sabihin ko, halimbawa kay MATLAB na KNN means, or sorry, not KNN, k-means o kaya KNN, yung ipaparun ko na machine learning algorithm. Tapos I will feed the data. So mano-mano ko siyang kinocode, katulad ng mga code na shinare ko sa inyo. Pero meron palang mas maganda, mas graphical na pwedeng gamitin kay MATLAB. So yun yung kanina ko lang na-discover, and probably it would be a nice thing to share with you guys probably next meeting. But this is what, hold on, let me shift to my MATLAB screen. Because one thing is, how do we know, or the question that you may ask is, how do we know that our algorithm is working well, right? There's no theoretical error bound that was given to us, right? Because really, for instance, the classification from KNN is based on the data that you feed into it, right? So yung classification niya kung nabase sa nearest neighbors ay nakadepende dun sa quality ng data na binigay mo, and how those data are nice discriminants or distinguishing factors para dun sa classification. Kasi imagine, kung ang ginawa ko dun sa classification algorithm, siguro, paglaruan natin, let me see. Bakit hindi pa rin nag-appear yung MATLAB? Sorry, nangangapa talaga ako sa Zoom hanggang ngayon. But anyway, let me share my entire screen. So, share ko pa yung screen, share button. Okay. So I hope you can now see my MATLAB screen. Okay. Ito yung pinaglalaroan natin last time. This is the same code. So we are using pre-saved data in MATLAB called Fisher-Irish. So ilo-load na lang natin yung data dyan. So ito yung apat na measurements for 150 sample specimen. So meron kang sepal width, sepal length, petal width, and petal length. And then, ika-classify natin 150 rows yan, is bawat isang row correspond to one particular specimen. And then meron tayong master list na yung 150 na yon pwede nating i-match into what variant or what species of iris they belong to, right? Tapos nakita natin, last time parang based on a simple scatter plot, nakita natin na mukhang magandang determinant or mas magandang determinant ng classification yung measurement 3 and measurement 4, which are the petal length and the petal width respectively. All right? Kasi kung titingnan natin yung graph nila, recap lang natin. So if you see this plot, let me just enlarge this. We see na magkakasama here in this corner yung mga nasa setosa variant, nasa medyo gitna yung mga versicolor variant, tapos nasa upper right-hand corner yung mga virginica, right? So it seems that petal width versus petal length are nice determinant. Of course, you could have chosen to include all other measurements into the training. Pwedeng i-train natin siya dun sa apat na parameters. Kaya lang, hindi ko kasi mapapag-graph yung kapag ka-apat na. Kasi I'll have a scatter plot in 4 dimensions, mahirap na siyang i-visualize. But yes, you can use more than 2 attributes or more than 2 characteristics para i-train yung data. Let me see. Pwede ko ang isama lahat eh. Kaya lang, hindi ko na siya mapaplot talaga. Pero try natin mamaya. Pag lahat ng measurements ay i-feed ko into the training dun sa machine learning algorithm. Okay? So nilimit ko yung training natin dun sa tatlong measurements. Columns 3. So ito yung declaration natin. So I am calling or I am saving into matrix X yung lahat ng rows ni matrix MES, which came from the Fisher-Irish data. Yung Fisher-Irish data may dalawa siyang laman. Isang 150 by 4 na matrix na ang laman niya ay yung 150 and then the 4 measurements. Tapos meron siyang species list na master list na nagko-correspond yung row number, nandun yung species niya. Tapos dun sa training, dahil based dun sa numerical evidence, I did the pre-processing of the data. Tinlot ko muna. Kinuha ko yung mga pares ng mga possible measurements. So kinuha ko paano kapag pinag-partner ko si sepal length at saka si sepal width. O kaya si sepal length saka si petal length. Do they discriminate? All right? With respect to the species na magkakaiba ba yung properties? Because I need to have a distinguishing characteristic. Pumili lang akong dalawa para ma-scatter plot natin. But again, you can try and use all of the training data or all of the measurements that we have as training data. Okay. So to limit the training data, ang kinuha ko lang yung third to the fourth column of the measurement matrix. Pero dahil column na nilagay ko dito sa first entry, lahat ng rows ay kinonsider niya. Wala akong init siya perang measured data. Okay? Tapos, ginamit natin itong KNN search, Euclidean distance, and so on. Okay? Para ma-predict yung classification ng query point natin na Y. Si capital Y ay ito. Halimbawa, meron akong isang flower na ang kanyang petal length ay 5 units, ang kanyang petal width ay 1.45 units. Tapos, tinanong ko kay model, kay KNN, ano yung posibleng classification niya or what do you think is the variant of that specimen? Ano? And this is based on finding the ceiling of the square root of 150 nearest neighbors kasi yun yung suggestion, though there is no theoretical proof for this. Pero ang usual choice for the K value, kung sino yung K na pipiliin natin na nearest neighbors ay yung ceiling o yung least integer greater than or equal to the number of training data. So basically, K here was computed as the square root of 150 and then I rounded up. And usually we want K to be odd, lalo na kung or not divisible by the number of species or the number of classification classes na meron ka para walang ties na magaganap. Alright? But that seldom happens, so you can leave it here and mag-decide ka na lang kung may tie, i-run mo na lang uli yung algorithm. But the algorithm is a little bit expensive because this is an exhaustive search. But I think MATLAB has some options to find the optimal algorithm para dun sa pagko-compute ng distance. Pero by default, KNN search that you see in line 15 will do an exhaustive search. Gagawa siya ng isang matrix na ang laman niya ay yung distances ng bawat point dun sa query point. Tapos kukunin niya yung square root of K na kukunin niya yung K na pinakamalapit doon sa query point. Okay? Now, okay, we could have run this. Sige na, run ko na lang siya para ma-save ko na rin yung data. Okay. So this is using the Euclidean distance. So ito yung 13 nearest neighbors ng query point natin, which is the black dot over here. Gamit ako ng annotator. So ito yung ating query point. And then ito yung 13 nearest neighbors niya with respect to the Euclidean distance. Okay. And then, nung nagbotohan yung mga yan, or when we counted kung saang variant nagbe-belong yung majority or yung plurality of those 13 nearest neighbors, sabi niya ay versicolor, yung variant ng mga yan. Okay? So that's how it is done. And again, as I mentioned, nakita na natin to last time, but let me again emphasize this point that nagbabago yung mga neighbors kapag binago mo yung distance. Let's say we decided to use the cosine distance, which is, I guess, the best example that I can give you kasi napaka-striking nung difference niya mula dun sa nakuha nating nearest neighbors with respect to the Euclidean distance. I'll hit F5. Hopefully, I don't have a close all command. Okay, I hope I don't. I think I don't. So ito yung ibibigay niya sa atin. So ito yung K nearest neighbors with respect to the cosine distance. And let me put it side by side with the K nearest neighbors with respect to the Euclidean distance. So ito yung galing sa Euclidean. Tapos ito yung galing sa cosine distance, right? And as expected, they will lie along the same line or along the diagonal line connecting the origin to the query point, right? Tapos ito naman, yung sa Euclidean distance, they will be inside the smallest, the circle with the smallest radius centered, containing all of those 13 plus the query point. Okay, so talagang magkaiba sila. Well, how do we measure the accuracy, or how do we get an idea kung dapat ba cosine o dapat Euclidean yung gagamitin kong algorithm? Well, we can test, we can validate our classification algorithm kahit gamitin na natin yung ating measurement data. So I will partition them into two classes. So meron akong data measurement. Yung 150 natin na meron, ginamit ko silang lahat to be my training data for this particular example. But I really want to have an idea, because if I will entertain a certain measurement, pinlogin ko siya sa machine, I don't have any idea kung tama ba yung binigay ng algorithm. What we just know is that that's the most accurate classification that we can get based on the KNN search and based on the distance or the metric that we declared. So ibig sabihin, paano kung gusto kong malaman sino yung distance na dapat kong gamitin, etc. So we can try to do some classification validation, okay, or cross validation. What I'll do is I'll split the data into two parts. Pero ito ay ano rin to, ang tawag, hindi to, what do you call this? I forgot the term. Hindi to theoretical. Walang theoretical basis ito. But again, data science usually rely on the central limit theorem, or the law of large numbers. The more data that we have, the better approximation that we get. It's like a hit or miss algorithm, like the Monte Carlo algorithm. So really, we will rely on the volume of the data that we have, or the training data that we have. So, but a practical way to test or to validate the algorithm, and especially this is useful whenever you're choosing what are the fine-tuning elements that I can put into my algorithm. Halimbawa dito sa KNN, anong klaseng distance dapat yung aking gamitin, all right? So pwede kang mag-cross validation. So you split your data into two, so into a training set and a testing set, or a validation set. Okay, just to get a feel of the accuracy of the measurements, all right? So ang gagawin ko ngayon, irarun ko yung same algorithm, say with the Euclidean distance, and then I will use the training set to get the model, right? So tapos ang gagawin ko ngayon, pag na-train na yung aking model, itetest ko siya ngayon dun sa aking specimen na alam ko na yung classification. And then I will look at ano yung accuracy percentage niya. Ilan dun sa mga testing set, not testing, validation, testing set, or ilang elements nung testing set yung na-classify niya ng tama. Kasi ngayon, alam ko yung classification ng mga nandun sa testing set, right? So how do we implement this in MATLAB? Well, I was, nung nalaman ko na meron tayong extra time na hindi ko kailangan palang bilisan at additional topic na next meeting, saka ako naisip, siguro mag-cross validation tayo. So let me go here. Okay. So here's what I'll do, right? So this is a simple code. The goal here is to get a what we call a confusion chart, no? So kita natin mamaya ano yung tinatawag natin na confusion chart. So first, I'll ask MATLAB to randomly partition the training set into two parts, yung training data natin at saka yung test data, or the validation data. So CV partition will do that. This is the cross validation partition. And I will partition them according to species, which is the classification, what do you call this? The classification classes. So tawagin natin yung species classification classes. So ito yung structure that will contain the classification of each of the 150 data that we have. Okay? So ang gagawin niya, CV partition, ipasa ko sa kanya yung master list ng mga species ng bawat isa dun sa aking mga observation point. And then the option holdout will tell MATLAB ilang percent yung gusto kong training data at ilang percent yung gusto kong validation data. I think here the 0.30 means that the holdout will be 30%, meaning 30% of the measurements belonging to species or belonging to the measurements that we have will be allocated to the testing or the validation set. So 30% pang validate, ang gagamitin ko lang pang training ay 70% of the data. Right? So yun yung gagawin niya. So CV partition will do that. And then I want to harvest sino-sino yung mapapalagay sa training set at sino yung mapapalagay sa testing set. Right? So what I should tell MATLAB is I'll create a variable named trained ins and test ins. So ibig sabihin yan, training indices and test indices. Ito yung row number ng mga pang training at row number ng mga pang testing. Actually, ano pala to? Logical matrix to na ang laman niya ay 0, 1. Sige, run ko nga para makita natin. So I'll highlight this, pati pala yung line 1, CV partition. I'll press F9. Okay, so on the workspace, I already have test indices and train indices. And if you click on them, it's a logical array. So it is an array consisting of 1 and zeros. Pag may 1 doon, ibig sabihin yung specimen number 1 ay nasa training set. Tapos number 2, nasa training set pa rin. Yung unang 0 dito sa training indices ay yung 8th row. Ibig sabihin, the specimen corresponding to the 8th row of my measurements is not allocated in the training indices. So doon siya pupunta sa testing data. Okay? So yung ginagawa niya. And then now, dahil na-harvest ko na yung indices, i-filter ko ngayon. So gagawa ko ng isang vector na X-train na ang laman niya lamang ay yung mga measurements para dun sa training data. Or dun sa mga para dun sa mga elements ng training set natin. So yun yung ginagawa ni MATLAB. So if you put in, so if you have the matrix X, ito yung malaking X natin kanina, 150 by 2, 150 rows corresponding to each of the 150 measurements. Tapos you have 2 columns, one for the petal width and one for the petal length, kasi yun yung preserve ko as my training or my attributes, my training attributes. Ang gagawin nito ay if-filter nitong command na to, yung matrix X, to include only those rows kung saan true yung laman ng train indices. Pero i-retain niya lahat ng columns. So ito yung parang pag-filter ng entries ng rows. Gusto ko lamang matira mula doon kay matrix X yung mga pang-training data. Na-save ko na, yes or no, nasa training ba siya or hindi. So ang gagawin ni MATLAB, hanapin niya lang lahat ng mga rows kung saan nag-yes ako doon sa training indices. Pero dahil colon, yung second component or second input to X, i-keep niya lahat ng column. Right? So ito yung pang-train natin. Ito yung training attributes. Ito yung mga measurements. Tapos kailangan ko siyang i-match kung sino yung o kung ano yung classification ng mga nandun sa training data. Right? So tinawag ko siyang Y-train. These are the actual classifications of the training data. So ganun din, species of train-ins. Wala na akong second component kasi 150 by 1 lang naman yung size ng species na list o na structure. So wala na siyang column number kasi it's either ang laman niya lang naman ay 150 rows, ng laman ay versicolor, virginica, or setosa. Alright? Tapos ganun din, ginawa ko yung X test at saka Y test na vector. Okay? So let me run this. Okay. And then you will see here that X test on my workspace. So andito siya. Ito sa workspace. So 45 by 2 na siya. Kasi ito yung 30% na testing data natin. So na-retain siya dun sa X test. And then X train, ito yung mga measurements, the petal length and the petal width corresponding to the 105 testing data that are generated by CV partition. Okay? Tapos kailangan kong i-store yung model into a handle, right? So itong line 12, dito nang gagaling yung training. pagtuturo natin dun sa algorithm kung paano i-classify, right? So para sa KNN, this is the command to create the model, right? Medyo kakaiba to kasi kita natin kung anong klaseng output nito. Kasi ito yung model na pwede kong pasa sa iba't ibang mga algorithms, right? And the prediction routine. So hindi kasi gagana yung KNN search. Kasi if you remember, I used KNN, a naive KNN command here. Ang ginagawa lang kasi ng KNN of something, kinukuha niya yung K nearest neighbors with respect to a certain distance. Hindi niya pinapreserve kung ano yung characteristics, ano yung decision algorithm para ma-classify yung isang query point. Kasi ito yung diretso. This is the naive implementation of the KNN search. Pero dito sa fit CKNN, nire-retain niya, ito talaga yung makikita ni machine. Parang nakastore kung ano yung algorithm na gagamitin ni MATLAB to decide kung kailan nagiging versicolor, kailan nagiging virginica, o kailan nagiging setosa ang isang query point, right? So FITC KNN model. Tapos ang first input niya, yung training measurements. Then the second component would be the species of your training measurements, all right? So dapat i-match mo na yung mga X-train, ganito yung kanilang measurements o yung mga attributes niya. I-match ko na siya kagad dun sa species. Tapos meron siya ditong name pair argument, num of neighbors, kasi kung ano yung K dun sa KNN, I guess we use 13. Siguro pwede ko nang gamitin yung K para pag binago ko yung code sa Irish KNN, automatically mababago rin to. Let me see if I can put distance here as yeah, I can put distance here. And let's say Euclidean. Okay. So para alam niya dun sa training, dun sa KNN training, na gusto kong gawin in line number 12, ang gagamitin niyang distance ay Euclidean distance. Right? So tapos i-store niya lahat ng natutunan niya dito sa fit CKNN routine into the variable handle MDL, or short for model. So model yung ginawa kong pangalan para sa kanya. So let's run this. And you see na tinitrain ko lang yung KNN algorithm using X-train, the 70% of the data that I have. Kasi tinira ko yung 30% for my validation. Okay? So ito yung in-output ng model, ito yung actual laman ng model. So response name is Y, ibig sabihin nandito dito siya pipili ng classification dun sa Y. And then categorical predictors, ito yung class names, dito siya pipili. Number of observations, 105, distance, 13. And then of course, nakastore na kay MATLAB. Once I call model, gagawin niya na yung prediction. I guess pwede ko nga ditong i-type yung hold on. Predict. So predict. Kasi ito yung pag meron kang model na nakasave, kapag ka gumamit ka ng fit CKNN or mamaya fit R3 or fit C3 yung gagamitin natin, pwede ko na lang yung query point, hindi ko na kailangan kumuha ng mga mode, etc. or gawin mano-mano. Actually, kanina ko lang natutunan tong predict command, kasi mano-mano kong kinompute yung mode, etc. But if you use the predict command, you just need to feed into the predict command. Andito pala ako, sorry guys, sana nakikita nyo. Yung predict. If you feed ko sa kanya yung model, okay, so ito yung model na tinrain natin galing sa fit CKNN or using the fit CKNN algorithm. Tapos ilalagay ko lang yung query point. Halimbawa, ano nga yung query point natin kanina? Query point natin kanina ay Y. Yung 5, 1.45. And then you see here that the output is clearly versicolor. Okay? Ito dun so kahit ginamit ko lang yung 105 training data, versicolor pa rin yung prediction niya dun sa specimen na sinubmit ko, dun sa tinrain ko using the entire data set. Right? But that's not really the point of this exercise. Gusto ko lang ipakita na paano yung cross-validation. Pero naalala ko yung predict algorithm, yung predict command. Kaya baka makalimutan ko later, kaya shinare ko na siya. Alright. So na-train na ngayon yung model. So pag meron ka ng model na nanggaling sa FITC, KNN, basta kinol ko si MDL, alam na ni MATLAB na, ito yung decision algorithm. Paano ako magka-classify? Ganito ko siya gagawin. Nakastore na sa akin ilang neighbors, paano pipiliin yung distance, and so on. Okay. Tapos ngayon ay itetest ko na siya. I-validate ko na siya dun sa ating mga testing data, right? I'm thinking, why do I have IDX rand sample here? Ng sum ng test indices. Kamatet. Aha. I forgot why is this here, pero siguro tingnan natin mamaya. So ito yung pinakita ko kanina. Line 15 stores into the label vector yung prediction using the model that we generated from line 12. Okay? Para sa mga query point na nandun sa X-test. So ito na yung 30% na ni-reserve ko kanina para dun sa validation. Okay? So, ipapredict niya, kukunin niya yung prediction, tapos i-graph niya yung prediction, yung confusion chart. I forgot what is this for. Y-test. So ito, okay. Tapos label, ang galing dito, variable names. Oh, I see. Parang dito ay pumili lang ako some test. Hold on. Yeah, let me just run this and see what will happen. Ano? Sama ko na, okay. Gandun sa table. Mm-hmm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I see. Ang ginawa niya lang ay, but I don't know why it is there. Siguro nag-run ako ng maraming data points. Kasi gusto kong makita ano yung sample. So ang ginawa ni line 14, nag-generate lang siya ng random sample out of the 45 testing data. Pumili lamang siya ng 10. 10 indices. So from 1 to 45, pumili siya ng 10. Tapos yung line 17 to 18, pinakita niya sa akin yung table comparison between the prediction and the true label. So for instance here, dun sa 10 random testing data na na-generate ni line 14, yung isa doon, versicolor yung totoo niyang label, tapos tama naman, versicolor yung na-predict sa kanya. Let's see, meron bang mali? Yeah. 2, 4, 5. Etong pang-5. So yung KNN algorithm natin o yung 13NN algorithm natin ay nagkamali dito sa pang-5 kong random sample. Because here, the true label is a Virginica, pero yung predicted label sa kanya ay versicolor. So hindi perfect yung algorithm. So dito pa lang sa random, nakakuha na tayo ng lapses, right? But let's see. To get a clearer picture of how accurate this is, usually we use the confusion chart. Okay? The confusion chart will tell us or will give us a summary, or actually this is sort of a matrix plot kung of the true label versus the predicted label. Kasi hindi tayo magpe-present. Halimbawa 45 yan, hindi mo yan ipe-present sa table. Nakatulad nito, 10 pa nga lang ang hirap ng i-discern kung maganda nga ba yung comparison or not. And so let's present our validation here using a chart, right? Yun yung confusion chart na tinatawag na nasa lines 20 to 21. So confusion chart, ang first entry niya ay yung prediction para dun sa mga testing points natin. So remember, we have the Y test. Ito yung true value. And label, ito yung prediction, right? Galing sa line 15. Itong Y test, siya yung nanggaling sa line 9, which is the actual species. So when you run this, let's see, 9, makukuha nyo to. Itong matrix plot nito. So the x-axis shows us the prediction class or the predicted class, and the y-axis shows us the true class. So meaning, halimbawa, itong nasa row na to, Ito yung mga totoong setosa, right? Tapos, 15 sa kanila were classified as setosa, none were classified as versicolor, and none were classified as virginica. Pero pag pumunta ka na dun sa mga versicolor among our testing data, 14 sa kanila were rightfully classified as versicolor, pero may isa sa kanila na na-classify wrongfully as virginica. Which is expected because remember the scatter plot, talagang naka-isolate yung mga setosa sa lower left. Tapos sa middle, nandun yung isa dun sa mga nag-start sa letter V. Tapos medyo malapit siya talaga dun sa isa pang class. So it's understandable and actually forgivable that our machine learning algorithm did not classify it well. Tapos yung virginica, ganun din. May isang virginica na na-classify as versicolor, but the rest, the 14, were classified rightfully as virginica. So you can tell here that okay, yung score niya, pwede natin siyang bigyan ng score. So itong KNN algorithm using the Euclidean distance was able to give us accuracy what? Dalawa lang yung mali, so we give it a rating 43/45. Okay? So that's how we interpret what we call a confusion chart. All right? So is that okay, guys? Hold on. Paano ko makikita yung... Oops. Yan. Okay. Kasi naka-full screen yung naka-share screen dun sa aking tablet. So hindi ko makita kung may reaction kayo or wala. So any questions with this? So far, everything's good? Okay, thank you. Tingnan natin. Ito yung hindi ko napaglaruan kanina. Pero ngayon ko lang na-realize or nung nagdi-discuss ako ng cross-validation, saka ko na-realize, try kaya natin na i-validate or gumawa ng cross-validation sa distance. Kasi hindi ko alam na pwede ko pala itong i-customize ng distance. So, you learn, actually dito sa klase na to, ang dami ko natututunan bago, especially with MATLAB. So, halimbawa, gawin natin cosine yung distance. Nasa option si cosine, right? Tingnan natin yung tingnan natin kung maganda ba yung makukuha nating result. I don't expect too much out of the cosine distance kasi dun sa isang example na ni-run natin kanina, parang hindi siya convincing. Kasi merong mga setosa, halo-halo pa rin sila. That's what I'm trying to say. But let's see, in this validation routine, is that the only thing I need to edit? Yes, that is. So, i-run ko ulit itong buong algorithm, itong buong script na to. So, ibig sabihin, mag-generate na naman ako ng random training set, random testing set, pero ang hatian nila ay 70-30 and so on. So, let me hit F5. Okay. All right. And you see, tingnan muna natin yung tabular. So, I pick out 10 random test points. So, medyo tumama naman siya. Versicolor, virginica. Hindi. Isa lang, may mali pala siya. Kala ko perfect siya. Alright? Masisira sana yung script ko kung perfect yan. Pero yeah, we see here. Sa 10, may isang mali. Pero of course, that's not what we want to see. Let's look at the confusion chart. Figure 7. There we go. Okay. So, makikita natin na okay, ilan yung mali niya? Medyo marami, no? Kasi 1, 6, 8, 9. Pero surprisingly mataas pa rin. This is a 36 out of 45 yung kanyang magiging score. So you can do this for all if you are trying to look for what the best or if you want to fine-tune your KNN algorithm, you can do a confusion chart by using a cross-validation using your entire data set. Na bago mo siya i-run into some query points, tingnan mo muna at least yung performance niya on a random partitioning of your data into training set and into a training set and a testing set, right? So you can play with it. I'll also share with you this not so pretty code. So if you are good at coding, So you can really fine tune this routine because I typed it as I go, ano. So kaya medyo mabilisan yan. At wala pa yung isipan ng efficiency. Kasi nga this is just an illustration. We have only 150 data, pero kapag malaki na yan, kailangan mo nang isipin paano ko magagawang mas efficient yung code. Walang redundant computations, taking advantage of MATLAB's say it's love for vectors kasi mas mabilis kay MATLAB, at least dati yung vectorized operations. Pero para ngayon humahabol na yung series computation saka yung parallel computation. So kaysa sa vectorization. But that's it. So you can play with the value of k, the number of neighbors that you want. Gawa kayo ng confusion chart, tapos i-record nyo ano yung score na binigay nyo. One simple measure of the score of your model is the number of correct predictions all over the number of testing data. You record them. You can make a graph with the score as a function of k, or the score as a function of the kind of distance or metric that you pass to it, para makapamili ka ano yung pinakamagandang parameters ng KNN na pwede kong gamitin pag sasabak na ako doon sa tunay na pagka-classify ng data. Kasi ito medyo contrived to kasi ang ginagamit nating pang test is something that we already classified. Kaya nga tawag sa kanya ay cross-validation. We're just checking the accuracy of our data or of our algorithm based on existing data. Okay? So yeah, so I trust that you will play with this. Aside from KNN, which is just a very basic algorithm, meron pang maybe I can share with you two more, namely Naïve Bayesian and the decision tree. Tapos meron pang random forest, meron pang logistic regression, but I will leave them as reading assignment to you, right? So lipat muna ako ng PDF annotator para ma-discuss ko ng konti yung theory behind or yung methodology ng Naïve Bayesian classification algorithm. So it's still another classification algorithm with the same goal as the KNN algorithm. Pero this time, iba yung kanyang pang-classify. It's a little bit more probabilistic. As the name implies, it's based on the Bayesian model for conditional probabilities. So mabilis lang. I don't want to go into too much details about probability distributions, etc. Isa yan sa mga pinaka-hate ko ng undergrad, probability. Kaya wishlist ko makapagturo ng 181 para ma-force ako na pag-aralan sila. So, but anyway, so Naïve Bayesian or Bayesian, however you call it, right? So it is sort of, it relies on conditional probabilities, right? So kino-compute niya ano yung probability that a certain attribute will belong to a certain class, or that a data point possessing certain attributes will belong to a certain class. Tapos kukompute niya to using the Bayesian theorem, okay, or the Bayesian formula for conditional probabilities. So you can think of this model as inference building based on prior occurrences or a priori known attributes that may imply the classification, right? And the assumption here is that the attributes are conditionally independent. Halimbawa, meron kang petal length dun sa ating problem, meron kang petal length, petal width. Ang assumption para magamit mo si Naïve Bayesian ay dapat independent yung petal width sa petal length. Because again, I'll be computing conditional probabilities, and conditional probabilities are easier to compute whenever the events are independent of each other. However, that doesn't happen too much in real life because usually the attributes that we have are somewhat related to each other. So there is an intrinsic or inherent relationship between the attributes. So yung Bayesian, yung assumption of independence required in the Bayesian model ay hindi siya nasa-satisfied. But surprisingly, the naive Bayesian technique still works even if the independence or the conditional independence between the attributes are not satisfied. All right? So kaya isa sa mga pinakasikat itong naive Bayesian. All right? Kasi nga madali siyang gawin, madali yung theory behind it, at madala siyang nag-work. Which I guess summarizes data science, ano? But anyway, what else? Oh, another advantage is that it is computationally cheap. I think it's much cheaper than the KNN algorithm kasi sa KNN algorithm, brute force yung ginagawa natin unless you will put some hybrid mechanism to it. But you're computing the distances for all of the measurements. So it's kind of an exhaustive or a brute force algorithm kasi isa-isa niyang kinocompute yung distances, isa-isa niyang kino-compare sa bawat isa, sa kanya kukunin yung mga closest neighbors. So if you will rerun the KNN algorithm, medyo mahal siya. Lalo na kung nagbago lang yung isip mo na ibang parameters, iba yung value ng K, iba yung distance na gamitin. So medyo mahal yung pag-rerun ng KNN algorithm. And hence, yung KNN, wala siyang extendability because you have to rerun everything. However, yung naive Bayesian has some provisions for extendability to larger data. Kasi yung computation time, physical and the number of operations wise para sa naive Bayesian approach is linear in time. So it's the running time is big O of capital N, where N is the number of data that you have, or the measure of data that you have. Kasi it depends how you will count the amount of data that you have. But anyway, it depends linearly on the size of the data that you have. And another thing is that naive Bayesian require relatively a small amount of training data. Kaya maraming gumagamit talaga ng Bayesian approach, right? But how does it work? Well, it is based on the Bayesian formula for conditional probability. So recall that the probability, let's just forget about the labels first. So the probability of C given X, so this is basically what's the chance that event C will happen provided that event X happen, is equal to the probability that X happened given C, or the probability that X will happen given that C happened, times the probability of C all over the probability of X. Ito yung directly nanggaling sa Bayesian formula, right? Now, if we will contextualize it with respect to classification algorithms, X could be treated as our attribute. These are our measurements, or these are the distinguishing characteristics, or the hopefully distinguishing characteristics that we have in our data. And then C is basically the class, all right, or the classes, the classification classes that we have. So basically, the left-hand side here is the probability that our query point belongs to class C, given that it has the observed attributes, all right? So probability na magbe-belong siya sa certain class given na siya ay ganito yung kanyang measurements, ganito yung kanyang attributes na pinapossess. You will compute this probability for all of the classes C, right? Kasi halimbawa dun sa example natin kanina na iris flowers, meron tayong dalawang attributes, right? Yung attribute natin for petal width and petal length, right? And then we have three classes, versicolor, virginica, and setosa. So you will compute the probability that the specimen that you have having attribute X. Now, X is a vector consisting the petal length and the petal width, that specimen will belong to classification setosa. You compute that probability, say set it aside. Then compute what's the probability that that specimen will belong to virginica provided it has the observed measurements. Set it aside and compute the corresponding probability para naman sa, hindi ko pa nasasabi, virginica or versicolor. Basta dun sa isa, dun yung natitira dun sa tatlo. And then ngayon, magpapataasan sila ng conditional probability. Alright? Now, continuous nga pala yung data ko, right? So, kailangan mag-decide ako kung ano yung probability distribution na gagamitin ko. Alright? Kasi madali ito kapag discrete yung data. So, meron ka lang discrete probability distribution. Halimbawa, ang data mo ay, ano ba magandang data? Halimbawa, nag-ano lang kami. Halimbawa, nanghuhula lang kami ng grade nyo. Alright? So, ang aking data halimbawa ay nakadepende halimbawa sa weather, yung grade na ibibigay ko sa inyo. Halimbawa, ngayon ay rainy, bibigyan ko kayo ng 1. Kung ngayon ay sunny, bibigyan ko kayo ng 2. Pero halimbawa, kinabukasan, nag-iba na ako ng isip, sige, pag rainy, bibigyan ko na kayo ng 2. Kapag sunny, 2 pa rin yung ibibigay ko. Tapos, ang pangit yung data ko, no? Pero, ito yung pinakasimple. So, rainy, tapos 1, nag-decide na naman ako na, okay, sunny. Maganda yung gising ko nung 3rd day, parehas 1 na, mapa rainy or sunny, and so on. So, makukompute nyo ngayon yung probability that I gave you an 1 given that it is sunny, right? Using this formula. Ano ba itong mga formula na to? Itong Px given C, right? Ito yung probability na yung specimen possesses a certain attribute given that it belongs to class C. So ngayon, pupuntahan ko ngayon lahat na nagbe-belong kay class C, ano yung probability na napopossess niya yung attribute X. Halimbawa, dito sa example na to, ito yung aking X's. My attributes are the type of weather that I have on that particular day, rainy or sunny. And then my classification is either 1 or 2. Okay? So pag kukunin ko yung probability, say that it is rainy, given that I gave you an 1, all right? Kailangan nyo lang bilangin, ilan dito yung nagbigay ako ng 1, 1, 2, 3. Okay. Kasi yun lang yung universe ko. What's the probability that it's rainy? Given that I gave you a 1. Right? So, meron lang akong 3 sa universe na yun kasi 3 beses lang ako nagbigay ng 1. And how many of them are rainy days? There are 2 rainy days among them. So, you get 2/3. Okay? So, yun yung probability na ito. Then multiply it by the probability that the class occurred. Right? From all of my data, what's the probability that I gave you an 1? All right. So that's 1, 2, 3, 3 out of 6. So that's 50%. Right? Then probability of X, what's the probability that it is rainy? 1, 2, 3. So that's also 50%. So, and then you plug those numbers into the Bayesian formula, you're going to get the probability that that a certain specimen or a certain measurement belongs to class C. All right? Tapos ngayon, kukomputin mo yan para dun sa measurement mo, kung ito ay rainy or sunny today. Tapos, halimbawa, ang grade kong binigay ay 1. So you can classify whether, you find the probability that I will give you an 1 given that it is, say, rainy. And then, or baliktad. Makukuha mo yung probability na yung grade na makukuha mo ay 1 given that it is rainy. And then you do it also, what's the probability that I gave you a 2 given that today is rainy. Kung sino yung mas mataas na probability, yun yung i-declare ng Naïve Bayesian algorithm to be the classification, either 1 or 2. depende dun sa probability, right? So that's how you do it in a discrete data. Yun yung kasi yung mas madaling i-interpret. But if your data is continuous, like what we have, actually hindi lang continuous pero siya ay two-dimensional yung data natin. Pero for instance, in one-dimensional cases, you get to pick what probability distribution you will use in the Bayesian formula to compute this probability. Or, sorry, to compute this probability. Ito yung mahirap i-compute kasi. Alright? Kasi ito, probability lang naman dun sa classification. So you can count your data, ilan doon yung nasa certain classification. That's the probability, right? And then P of X is actually a constant. So usually we don't care about P of X because this is the probability that a certain attribute is met. So pwedeng hindi na natin to i-consider. Kasi actually, ang kukomputing ko lang naman yung probability that I belong to all of the classes, to each of the classes, if I attain attribute X. So doon ako magpapataasan. So I'll have PC1 given X, PC2 given X, PC3 given X, and so on. Hanggang marating ko yung number of classes. And this is not dependent on the class. Fix kasi yung X na kukomputan ko ng conditional probability. So really, this doesn't matter. So ito lang usually yung tinitingnan natin. Now, this is hard to compute, especially if your data is continuous. So you get to pick your probability distribution. A common assumption, of course, is that the data that you have follow the normal distribution. So you will use the probability that X is equal, say, to a measurement V, given that it belongs to class C, is equal to 1 over square root of 2 pi sigma sub C squared, where sigma sub C is the variant, sigma, no? Sigma is the standard deviation on class C times E raised to the negative nu sub C minus mu sub C all over 2 variance squared sub C, naka-square pala yung numerator. So your usual probability distribution function for the standard, for the normal distribution, where your parameters here are, actually, hindi pala to nu, ito ay V lang, sorry. Okay. Where your parameters are mu sub C and sigma sub C are the mean and the Bessel corrected standard deviation inside a class C. All right, so titingnan mo yung class C ng data mo, ito yung gagamitin mong probability, so makukompute mo na ito, right? And you can pick your own probability distribution, so you can do a pre-processing of your data, of your training set. Tingnan mo ano yung probability na fina-follow niya. Yun ay kung siya ay continuous. Yun lang naman yung mahirap i-compute kung siya ay continuous. Okay. But going back to this formula, okay, we can actually remember this formula and find the reason why the setup is like this if we know how to interpret things. Again, this is what we call, technically, this is what we call the posterior probability. Meaning it is after the fact. After the training occurred, ito yung probability na makukuha natin. This is our prediction. This is the posterior probability that our observation data or our query point belongs to class C, given it possesses the attribute X, right? So kaya siya posterior. Well, this probability can be interpreted as our predictor probability. Ito yung predictor ng given class. Okay, so what's the probability that a certain specimen that a certain specimen have the attribute X given that it belongs to the class C, right? And then this is the prior probability of the class. it is prior yung tawag kasi siya yung before the training. Kasi nandun na siya sa data, bago ko pa siya ipasok sa training, predetermined na yung probability na yun. What percentage of my training data belongs to the class C, right? So essentially, this naive Bayesian formula actually can be thought of in layman's terms to be the posterior probability, which is basically our prediction, is equal to the prior probability. Kasi ito nga yung sa prediction, predictor given class, right? So prior probability times the likelihood. Likelihood that a certain observation will belong to a certain class divided by the evidence. The evidence is the probability that you get or you observe a certain attribute. Okay? So that's the idea behind the naive Bayesian approach. So ready na for machine implementation? At least you get an idea how this works. Of course, mahirap computin yung probabilities. Ano? Aminado ko, mahirap computin yung probabilities. I really hate probabilities. Pero luckily, marami ng mga intrinsic built-in commands ang mga programming languages para computin itong distribution na to or para computin itong mga probabilities para sa atin. Kaya nga, mag-feed na lang ako ng data, magra-run na yung naive Bayesian algorithm. Okay? So, questions? Lipat ulit ako sa MATLAB. Oh, by the way, what do you think of using MATLAB? Pasensya na, because I really hate Python. Hindi ako matututo ng Python. Kahit na sinasabi ko nga ang ano lang naman, ang programming ay dapat programming language independent. Because once you know the language, syntax lang naman yung babaguhin mo. So parang nagka-translate ka lang from one dialect to another. Parang ganun lang yung datingan. Pero hindi ko talaga masakyan yung paraan ng pagko-code kay Python. Kaya nga pinag-aaralan ko ngayon ay paano mag-run ng Python packages kay MATLAB. Nag-attend ako ng isang webinar para doon. Para hindi ma-circumvent ko yung distaste ko para kay Python. But if you love Python, then you can probably run everything here in Python. But let me stick to MATLAB. Saka sayang kasi yung subscription ng UP. So kung hindi naman natin gagamitin, mahal magka-MATLAB. So let's make the most out of it. Okay. Tingnan natin yung naive Bayesian approach. Actually, maiksi lang to. Yeah. I'll load the same database or the same set of measurements. Pero ngayon gagamitin yung nasa Fisher-Irish. Pero gagamitin ko na yung buong dataset to be my training. Right? Gagamitin ko lahat ng measurements, yung 4 na measurements. Hindi na ako malilimit doon sa petal width at saka petal length. Sasama ko na yung mga measurements ng sepal. Kahit na alam ko at the back of my mind that that's not a good distinguishing or those are not good distinguishing characteristics of the Irish flower, but I have the data nonetheless, the more the merrier. So I'll load them into my matrix X, right? Tapos andun pa rin yung species na manggagaling kay Fisher-Irish database. So nakasave kay Fisher-Irish yung species, which is the master list, matching the measurements to the actual species observed. Lalagay ko siya sa matrix 1. Okay. Tapos, magta-train na ako ngayon ng model. Paano ko iti-train yung algorithm? Yung model, tatawagin ko lang si fit CNB. So I'm fitting a naive Bayesian, kaya siya NB. Naive Bayesian kasi yung approach. Kanino ko siya gagamitin? Kay X at saka kay Y. Alright? So these are the measurements and this is the código. This is the master list ng mga species nila. Gagawin niya na yung mga probability computations na ginagawa natin kanina. So we won't need to worry about what type of probability. I guess here the default is it will assume it's standard normal. It's a normal distribution. Let me just check. What are the possible name pair? Yeah, distribution. I guess the basic is normal. So pero tanggalin ko na yan kasi siya naman yung default. So let me just run it simply like that. Tapos nagawa na kagad ako ng X-test. Halimbawa, magpapasa ako ng 5.8, 2.85, 45. Ito yung na-observe ko in nature. Gusto kong ipa-classify sa ating Naïve Bayesian model kung siya ba ay versicolor, setosa, or virginica. Tapos may isa pa. So pwede nga yung testing natin ay multiple measurements. So i-store mo lang sila into a matrix of an arbitrary number of rows but the same number of columns as the training set. Dapat 4 yung measurements na ilalagay ko. So I made up some numbers over here. Ano lang yan, kung ano yung natipuhan kong i-type kanina. And then I will use our model obtained from Naïve Bayesian approach from line number 5 to predict kung saan nagbe-belong yung mga X-test. And I will store kung saan sila nagbe-belong o yung prediction para kung saan class sila nagbe-belong dun sa variable na class out. Lagyan ko siya ng semicolon para hindi niya ipakita sa window, dun sa command window yung sagot. Iko-call ko na lang siya mamaya pag kailangan ko na siya. Kasi medyo annoying pag makikita ko siya doon. Oh, actually, hindi pala masyado kasi wala na pala ako masyadong gagawin. Figure na yung susunod. Now, dito sa figure, anong ginagawa niya? Okay. So, dito sa figure na to, pinascatter plot ko lang uli yung petal width, petal length, and the species. Tapos, i-compare ko siya dun sa aking test points. Para lang makita ko kung nasan siya with respect dun sa scatter plot natin na nakita kanina. Although, I would just like to remind you na hindi ako limited dun sa petal measurements, dun sa third and fourth columns ni measurement matrix. Ginamit ko yung buong measurement matrix para sa pagte-train ng ating data. Right? So, I'll hit F5. And then here, in the command window, I have here the classification output. The prediction of our Naïve Bayesian algorithm using the normal distribution or assuming the normal distribution ay yung una nating specimen with the measurements 5.8, 2.8, 5, and 1.45 is most probably, with respect to the normal distribution, a versicolor. And the second specimen, most probably, with respect to the normal distribution, is a virginica. Yun yung kanyang prediction. Tapos tingnan natin yung plot. I'm just curious what happened here. Yung una nating test data is here. Ito yung una nating test data. And I really designed this so that it will be right along the boundary of the virginica and the versicolor variants. Ano? And ano yung hula sa kanya? That's what? That's data... Oh, hold on. That's data what? That's data number 1. So versicolor, yung classification sa kanya ng ating algorithm. So yun yung kanyang prediction. It's versicolor, which is acceptable kasi malapit siya dun sa mga red. Dun sa mga orange, not so much. I think even the KNN algorithm will predict that it is a versicolor if the Euclidean distance will be used. Luckily, hindi siya setosa kasi ang layo niya dun sa mga setosa. Pero nasan pa yung isa kong data point? Yung isa kong data point kasi naligaw. Nandun siya sa taas. Mag-zoom out lang ako. Yun. Andito siya sa taas. Alright? So, extreme kasi siya. Ginawa ko ba 0? Ginawa ko 0.5 yung kanyang 0.5 yung kanyang third component, right? Kaya ano ba yung third component? The third component is the x-axis over here, kaya siya nag-0. I forgot what's the axis here. Hindi ko na siya makita. Pero yan, that's a prediction. Okay. Now you can play with the kind of distribution that you want the Naïve Bayesian approach to use to train your data. Okay. So, ano ba yung mga options natin? Yun yung gusto ko kay 2022B. This is the first MATLAB version that I tested, that I used, na pinapakita sa akin yung mga name pair arguments na posible sa bawat command. I don't know kung yung 2021 ay ganito na rin. The last version I used prior to 2022B, the latest version, ay parang 2020 pa yung huli kong ginamit. So, medyo updated na. So, you can update your MATLAB consoles kung hindi latest or kung walang ganitong feature. Kasi I find it extremely helpful, especially if you're studying the different possibilities for a certain command, right? Line number 5 pala ako dapat. So I can now dictate what's the distribution name that I'm going to use for the fit CNB algorithm. Halimbawa, kernel distribution yung gagamitin ko. I'm not familiar with the kernel distribution, pero sige, try lang natin out of curiosity. How will the result look like? So run this, at makikita nyo iba yung prediction kapag kernel yung inassume natin na distribution, or if we assume that our data measurements are in a kernel distribution, right? So pareha sila dun sa prediction dun sa una, parehas versicolor yung kanilang prediction, pero nagkatalo sila dun sa prediction dun sa second data. Virginica yung normal, setosa yung kernel. And I think this is understandable because the second measurement is kind of an outlier, right? Kasi 0.5 yung kanya, alam ko na dito at the back of my mind that the distinguishing factors are really the petal length and the petal width. And 0.5, 10 is a measurement all the way up and to the left. Nasa upper left siya. Super upper na ang layo niya sa setosa. Ano? Malayo rin siya dun sa virginica and versicolor. Nakita natin to sa scatter plot kanina where I needed to zoom out para makita kung nasaan yung second query point ko. Right? Now, if you want to know the documentation, ito rin yung isang mahalaga, and this really what led me to several discoveries about this MATLAB routine. No? I can right-click on the certain command that I want and click help on that particular command, or simply highlight what you want to search on and press F1. Okay. Tapos, ilalabas ni MATLAB yung kanyang pop-up dialog box containing the documentation for that particular command. So pinakita niya sa akin dito yung fit CNB na documentation. Well, to see it clearly, I can click open browser para meron akong full screen na mababasa kung anong ginagawa nitong fit CNB. And then here you go. Papakita niya yung mga posibleng syntax para kay fit CNB. Then it has some examples. Dito ko lang nililift yung mga examples na pinapakita ko sa inyo. Alright. Then step by step to. So pinapakita niya pagka nirun ko to, ito yung magiging output. That was dinideclare niya kung ano yung nangyari, kung ano yung ginagawa nung command na yun. That's why I really love MATLAB kasi ang dali niyang pag-aralan on your own. Kasi meron siyang mga pa-examples. And then meron pa siya rito possible input arguments. So ito yung mga posibleng ipasa mo sa kanya. And then the customizable parameters, yun yung tinatawag natin na name value arguments. So halimbawa, ito yung mga options para sa Naïve Bayesian algorithm. Ito yung mga options natin para sa data distributions. Kernel, tapos sinasabi niya rito kung ano yung description, ano yung kernel algorithm. Kapag ka MN yung tinype mo, multinomial distribution yung gagamitin niya. Right? And so on. So, 4 yung posibleng distributions na gamitin nyo. And may further option pa para sa kernel. So, meron kang box, Epanechnikov, normal, triangle, etc. I don't know what they do, pero in the future, they might be helpful, especially kung nagpa-fine-tune na kayo ng training. So, tingnan nyo na lang yung documentation. Okay? Now, or in parallel to what we did with the KNN algorithm, I can again perform a cross-validation for the Naïve Bayesian approach. So I'll just uncomment these lines here, which basically generates a confusion chart for the Naïve Bayesian approach. So run ko lang yan. Tapos ito yung normal, no? So ni-revert ko to normal yung probability distribution na ginagamit, right? And then let me see kung tama na to. Okay. So I don't need this line. This is already above. And then ito uli yung random, tapos confusion chart. Let me generate another figure window there para hindi siya pumatong dun sa figure previous windows. Then let me run this. Okay. So, okay, let's see this. So ito yung random samples mula dun sa prediction. I guess dun sa 10 nabunot natin, perfect yung classification. Pero dahil random lang to, i-double check natin by looking at the confusion map, right? So yung confusion map para dito sa normal distribution ay ito. And I guess this is much accurate than the KNN algorithms that we have seen earlier kasi dito isa lang yung mali niya. It incorrectly classified a versicolor specimen as a virginica. But other than that, everything worked well, right? So, tingnan. So, ito yung score. So, we can give the normal distribution in the Naïve Bayesian approach to have a score of 44 over 45, right? So, let's try yung kernel distribution. Para malaman natin ano yung pinakamagandang distribution na gawin. And everything here is happening posteriori, ano? Kasi beforehand we don't have any analytic tool to predict what's the best one. Unless you will do a data preparation, a data analysis, then you should be good. Pero otherwise, kailangan natin tong i-run ng paulit-ulit and do a validation. Oh, sorry. Mali yung pinagtatypan ko kaya hindi nagpa-pop up yung options. I should be in line number 5. I'll have distribution names. And then gawin natin kernel. I'll run the cross-validation along with the training. And then we'll get this. Oh, yung kernel, perfect. Yung kanyang pagkaka-classify. Perfect 45. Right. What are the other options aside from kernel? We have the multinomial distribution, MN. I'll hit F5. Hindi pala siya pwede. Right. Kasi ang sabi niya rito ay dapat yung input data ay non-negative integers lang para sa multinomial distribution. So that is not applicable here. Hindi ko kasi binasa yung documentation ng MN. I'm just trying all the options here because I'm fishing for the best distribution. The multinomial, what is MVNN again? I forgot what this is. Did I close the help button? Documentation page. Fortunately, I closed this and I have a memory of a goldfish, so hindi ko na kagad tanda kung ano yung ibig sabihin ng MVMN. Ito ba yung multivariate multinomial? Tama ba? I'm guessing kasi hindi ko natanda kung ano yung distribution na yan. But you can go back to the documentation page to see exactly what it does. Right? So I think that's may isa pa sana, which is the decision tree. If you will lend me 5 more minutes, I'll be happy to demonstrate the decision tree. You know, magsusulat, sabihin ko na lang. Yung decision tree, siya ngayon ay gumagawa ng parang isang flowchart on how to proceed. And generally, the decision tree is binary in nature, right? So it will what do you call this? It will generate a sequence of questions that will cause the branching out of your decision-making process into 2 at every step that nasusundan mo para ma-classify mo kung saan magbe-belong yung isang query data, right? So, halimbawa, meron kang 4 na attributes. Halimbawa sa example natin, meron tayong petal length, petal width, sepal length, sepal width, right? So, meron kang 4 na yon. Ang gagawin ni decision tree, mag-start siya sa taas. Tapos i-determine niya ano yung unang pinakamalaking distinguishing factor among the three classifications. So I have 4 measurements. It will decide alin dun sa 4 na measurements na yon yung pwede kong gamitin para mag-decide kung saan siya magbe-belong. It will determine, halimbawa, yung 3rd measurement, yung napili niya. It will have an internal arrangement. Pwede nating balikan yung documentation at the start of next meeting. So it will decide. And then it will also decide what's the decision, what's the question that should be posed. Ano yung criteria para pumunta siya sa option number 1 at option number 2. Right? So yung mga options na yun na tinatawag nating mga leaves, o bawat isa sa kanila ay mga leaf nung tree, right? Siya yung magsasabi, do I have a decision or do I post additional questions? So parang ganun yung mangyayari. Siguro it would be better if I will show you an instance of a decision tree. Isa lamang criticism para sa decision trees, napaka-unstable niya. Meaning small perturbations in the data will generate completely different results. Right? So let me just clear the workspace, close all graphs, and then clear the workspace, starting fresh. So, okay. So, ilo-load ko si Fisher Irish. Gagamitin kong training lahat ng measurement data. Nandito yung species master list. Para i-create yung model para sa decision tree, gamitin nyo lang yung code na fitc3. Yung fitc3, ang inputs niya ay X and Y. I'm not familiar what are the other name value arguments, but you can play with them. Sabi rito, pwedeng mamili ka ng algorithm for categorical predictors, class names, and costs. And then once you choose them, may kita mo kung ano yung pwede mong pagpilian sa kanila. So dito ay number lang pala yung dapat mong ilalagay, isang value, right? But anyway, I'll just go with the default. All right. But again, I want to remind you na ginamit ko lahat ng 4 na measurements. You see, my training data ay lahat ng measurements. Wala akong init sa pera. Okay? So, ito, I am training my machine to use the decision tree algorithm para sa classification routine. I-store niya lahat nung nandun sa classification algorithm na matututunan niya based on the data that I fed to it into the model called Model 2. Right? Choice ko lang na tawagin siyang Model 2 kasi kanina sabay-sabay ako nagra-run. So I will run this. Okay, run ko yan naka-highlight. So I will have here, I have a classification tree rito na isang special variable. Then if I want to see what is the result of the classification model, I can tell MATLAB that I want to view Model 2, right? View of MDL2. It will give me a textual description of the decision algorithm. Press F9. So makikita nyo dun sa command window, ito yung decision tree para sa classification. Yung unang decision ay if X3, meaning the 3rd measurement. If the 3rd measurement is less than 2.45, then pupunta ako sa node 2. So pag yung measurement, yung query measurement ko, 3rd entry niya ay less than 2.45, pupunta ako sa node 2, na-classify niya na, setosa yung sagot. Else, kung hindi 2 yung node, kung hindi less than 2.45 si X3, then pupunta ako sa node 3. Sa node 3, ito naman yung susunod na decision point. Pero kung kung hindi niya na-satisfy itong dalawa, then setosa pa rin yung kanyang classification. Although that should be null because this is X3 less than 2.45, X3 greater than or equal to 2.45. So I don't think there's something to that else statement because decision trees by nature are binary. So dapat dalawa lang yung possible options. So this is kind of a textual flowchart na pwedeng i-follow pag magde-decide ka na. But it is better seen as a graph. So tingnan natin tong number 8. So I am viewing the same model, Model 2, but the mode of viewing now is graphical. So yan yung command. I'll hit F9 in my keyboard. I'll get this. Ito yung tree viewer ng classification. So you'll start at the top, and here it's a decision point, right? So the rule is check if x3 is less than 2.45. If it is, then pupunta ako dito sa left leaf, setosa na kagad yung classification. Otherwise, if x3 is greater than or equal to 2.45, I will go to the left leaf, to the right leaf. Yung sa right leaf, sorry, medyo maliit yung font. Dapat pinalaki ko. X4, meron kang uling decision point. X4 should be less than 1.75. If that is true, pupunta ako dito. Otherwise, dito ako pupunta. Virginica na yung classification. Right? Pero kung umabot ako dito sa leaf na yan, it's another decision point. Either x sub 3 is greater than 4.95, doon ako pupunta. But if it is not, then automatically Virginica na yung classification. Right? Tapos, dito na ako sa last leaf. Magba-branch out siya sa dalawang options. Pero ang kagandahan dito, nakadepende na lang kay x4 yung classification. If x4 is less than 1.65 or if x4 is greater than or equal to 1.65, madedetermine ko kung versicolor or Virginica yung aking specimen. Okay? So that's this decision tree. And the nice thing about this is I didn't feed the machine with the decision parameters. Saan nanggaling yung x3 dapat less than 2.45 para maging setosa siya? Well, it's based on the analysis of the data, right? Maybe we can take a look at how this was decided. Paano nakuha yung threshold na yon at the start of next meeting. But finally, super overtime na, pero alam kong dinner na kayo. Last na. Paano natin gagamitin yung model to predict? Well, we will just use the predict command. Basta yung training nyo ay nagsimula sa fit, ibig sabihin, pwede nyo gamitin yung predict. Right? So I'm gonna predict kung saang class nagbe-belong itong measurement na to. So ito yung measurement ko, 0055 from a specimen. And I will use model 2 para i-predict kung anong class siya. Nakasave kay class predict kung ano yung prediction. Right? So let me run line 10. And here, it's a Virginica. So 0055 Virginica yan. Tapos if you want to verify this, kung diskumpiyado kayo kay MATLAB, sundan nyo tong rule na to. Yan, decision tree classification rule na yan. Or you can go to the graphical approach. Kasi check nyo, dun nga ako mag-end up kay Virginica. And then you can also do a cross-validation para kay Irish tree. So you can just copy-paste the cross-validation routine that we use dito sa Bayesian at saka din sa KNN approach para sa Irish tree. And then the nice thing about this is that the scoring mechanism that you get from the confusion map dun sa cross-validation, pwede nyo siyang gamitin not just in finding the best parameter for a certain routine. You can compare different routines or different kind of classification algorithm para makita nyo sino yung may pinakamataas na score. Because most probably, kung sino yung may pinakamagandang score, siya yung pinaka-applicable dun sa ating data. Right? And what I'll do next time is I'll probably share with you what I discovered earlier today na madali palang gamitin yung meron kasing app si MATLAB na ang tawag ay classification learner, right? So we'll explore the classification learner application next time. Mabilis lang siguro 30 minutes and then pupunta na tayo sa ilang clustering algorithms, right? But there are some other classification algorithms that you want to read about, yung random forest, which is basically an extension of the decision tree. Yung decision tree kasi binary lang siya. Yung decision forest, which is a term borrowed from graph theory, iba't ibang trees. Talagang literal. Na iba't ibang trees, they constitute a forest and you're gonna use all of those trees to get an inference about the classification of a query data. Tapos meron pang isa, logistic regression. You can read about it, but we can also include it in our classification learner application next time. Right? Exactong 7 o'clock. So, i-stop ko na yung sharing kasi baka may masasabi pa akong iba. Ano? Sorry for keeping you 10 minutes more than the intended class time. But do you guys have any parting questions, burning questions na hindi nyo kayang itulog at or i-email sa akin? Wala na? Oh, mabilis lang pala. Presentation, sinabi na ba ni Sir Jomar kung ano yung ano? Kung ano yung ipapresent nyo? Kasi tininan ko yung calendar. So hanggang December 9 ako. Tapos yung next week ay presentation nyo. Magsa-sample presentation si Sir next week. Tapos yung susunod na 2 meetings after that, kayo yung magpe-present. Sinabi na ba niya kung ano yung ipapresent niya?
Pero naalala ko dati, ang sinabi niya i-present ay portfolio.
Yung
Kung tama
portfolio. So kailangan tapos
ba?
So dapat tapos na kayo sa mga problem sets. Hindi pa
Pero
ako
hindi pa final yung problem set.
hindi pa ako nagbibigay ng pangatlong problem set eh. So
Kaya po sir,
pag-isipan
pa-verify na lang po.
ano na?
Pa-verify na lang rin sir kay sir kung ano talaga yung
Tatanong ko kasi Kasi kung pwede kong kunin yung isa pang meeting para mag-share ng iba pang mga methods or iba pang mga insights at paglaruan pa rin natin si MATLAB ano. Kung wala pa siyang na-schedule talaga na gagawin for the presentation. And I still owe you probably one last problem set. And then I will ask you to, halimbawa, ito yung naisip ko sa problem set para lang meron kayong mabilis na idea. Ay mag-collect kayo ng data na pwedeng gamitin sa clustering at saka sa classification algorithm. Parang similar dito sa Irish data. So you can go kung anumang klaseng data yung interesado kayo na pwedeng gamitin sa clustering at saka sa classification. Una, clustering kasi gusto ko munang i-try yung unsupervised learning. Sa clustering kasi, yung algorithm mismo o yung machine mismo yung mag-classify. Kasi dito sa ginawa nating classification, supervised ito, meaning naka-cluster na yung mga training data. Alam na natin kung saan sila magbe-belong. Ang problema lang natin ay mag-classify. So para isang problem set na lang, yung clustering at saka classification, what I want you to do is collect some data that are of interest to you, kung ano man yung field na gusto nyong paglaruan, ano? Tapos mag-apply kayo ng clustering algorithm sa kanya para kahit alam na natin, yung clustering itago nyo muna outside of the machine para lang sa cross-validation natin. Pero mag-clustering kayo. Pabayaan nyo si machine na manghula ng ano yung clustering, ano yung grouping ng mga data set. You might need to declare how many clusters there are, but do not tell the machine na kung ano yung clustering mismo o yung ano yung grouping, yung classification mismo. Kasi yun yung gusto nating tingnan, how accurate was the classification. Tapos depende dun sa classification na ibibigay ni machine, saka clustering na ibibigay ni machine, saka tayo magbibigay ng classification problem. Right? So saka ako magbibigay ng, halimbawa ito yung measurement ko, classify mo nga to kung anong klaseng dahon to or something like that. Ano? So that would be the problem set, but I'll write a detailed explanation about it. And dahil super late ko na siyang mabibigay, I will tell Sir Joms kung pwedeng January ko na siya ipapasa. Kahit out after na ng presentation ng portfolio nyo, because I don't want to give you too much of a burden for the next 2 weeks of classes. I know you have a lot of things going on, so yeah. Okay, so that's it. I'm keeping you longer than what is intended, so thank you guys for coming today. We'll see each other again on Friday. All right, bye guys.
Thank you sir, bye-bye.
All right.
Thank you po, sir.
You're welcome. Paano ko to itatapusin?